Hey that 5, I hope you've watched the video on the titration experiment before you've watched this, okay? But I'm just going to very quickly run through the pieces of equipment again. So this here is a Buret, okay? That's the tap that we were talking about in the previous lesson. So if it's perpendicular to the Buret, it's closed, and if it's parallel, yeah, runs in the same direction, it's open, okay? And you'll see that the liquid, obviously we pour the liquid in at the top here, and the numbers go from 0 all the way to 50. Okay, that's just the measurement of how much we have, so in centimetres cubed. Okay, so what happens is we fill the liquid up, okay, and let's just say we get a value of 2. Now it doesn't have to be 0. A lot of people fixate on trying to get 0. It doesn't have to be. Let's just say we filled it up and it went to 2. Okay, and then we opened our tap, and then the liquid started to pour out. Okay, and then what happens is we get a colour change, and the second we get that clear colour change, yeah, we stop it. And let's just imagine we stopped it at 10. So our initial reading was 2. Our final reading was 10, so that means our titer value, how much liquid we've used, is 8. Okay, so our initial reading was 2, our final reading was 10, so our titer value, how much we've used, is 8 centimetre cubed. Okay, now Buret's very accurate, okay, and obviously it can measure a variety of different measurements. However, in the video it was spoken about the pipette, okay. Now the pipette is the most accurate instrument you'll come across at Nat 5, okay, and it looks like that. Now what you'll see is there's no markings on this, okay. This is a 20mm pipette here, and there's no markings on this until you get up here, okay, and you'll see a line that just goes all the way around. At this point, that is 20 mils. So if you fill up your liquid, okay, and you get to that line, that is 20 mils. And the man also spoke about the meniscus. Now, naturally, as the guy said, the meniscus, the liquid sort of curve at the top, okay, and it's very important when we take our measurements that when the liquid sort of curves, we take our liquid so that the bottom of that curve, the bottom of the meniscus, touches that line. Okay, that's so important. Yeah, and that is our 2 measurements. So, what we're going to do, this is our title for today, Titrations Part 2, and it's Lesson 9. So what I'm going to do is I'm going to go over the equipment. I'm going to give you the note on it, okay, and then we're going to start looking at a calculation again. So equipment, so we add solutions into our conical flask. Okay, and you'll have seen a conical flask. I'll get you one just now. This is what a conical flask looks like. Okay, so that's the shape of the conical flask. And it's a lot easier to use this because there's less splashing, so much easier to use that. So we add solutions into our conical flask using a pipette. Okay, now the thing about the pipette, this is an extremely accurate piece of equipment. Okay, very accurate is the pipette. However, it does have a downside. Yeah, if we go back here, you'll notice this is a 20ml pipette. So if we get to that line, that's 20ml. The downside to this is that this 20ml pipette can only measure 20ml. Okay, if we wanted 10ml, we would need to go out and get a 10ml pipette. If we wanted 15ml, we would need to go out and get a 15ml pipette. Yeah. So, however, we can only measure one volume. Okay, and like I said, 25ml pipette measures 25ml. 10ml pipette only measures 10ml. Okay. The next piece of equipment is the Buret. Okay, so Buret is used when we are adding a reactant to our other reactant. Okay, and that's the one that's inside the conical flask. Okay, that's the one that's inside the conical flask. Now, just a wee sort of side note. Okay, the Buret isn't as accurate as the pipette. Okay, but we can get a variety of different measurements. Okay, and you can see that. Yeah, there's loads of markings on the side, but it's not quite as accurate as the pipette. Okay, so we'll make a wee note about that. Not as accurate as a pipette, but has a variety of measurements on it. Okay, and the good thing about obviously the Buret, we do use it in titrations, but it's also it's far more accurate than a measuring cylinder. Okay, normally in chemistry when we're measuring solutions, you would use a measuring cylinder. However, the Buret is far more accurate. So it's far more accurate than a measurement. Than a measuring cylinder. Okay, and the last thing I want to talk about is the meniscus. Okay, so it's not a piece of equipment, obviously, but I'll give you a wee note on the meniscus. So when filling the Buret or pipette, yeah, we always take our value from the bottom of the meniscus. Okay, now that there is so important. Okay, we take it from the bottom of the meniscus. Yeah, and if I just do a wee sort of diagram here, we'll make it whole numbers just to make it a lot easier. Okay, let's just say the meniscus went like that. Okay, because liquids, they naturally curve at the top. So instead of reading it at 12, we read it at the bottom of this meniscus, the bottom of the curve. Okay, that's what the meniscus is. It's that curve found at the top of the liquid. So we take it from the bottom of the meniscus, which would obviously be 11. Okay, so the reading should be 11, not 12. Okay, and you should be starring that because it's so important that, yeah, the bottom of the meniscus. Right, what we're going to do now, we're going to look at we're going to do further work on our calculations. Now we should already be quite strong with splitting the page into 3 and then using our brand new equation when it comes to titrations, N equals CV, okay, and then C equals N over V and so on. Now we're going to do exactly the same thing, but I'm going to sort of present the question in a more awkward way, okay? I'm going to give you a table to give you results in the table, and what you need to do as chemists, you need to be able to extract that information from the question and then use it in your answer, because once you've got all the information, once you've written down everything that you know, these questions are easy, okay? It's an easy 3 marks. So let's write our question then. So a titration experiment was set up as shown. Okay, now this experiment here, I actually did this myself, okay, so all the results are mine. Yeah, now what we're going to do, just going to use a ruler. Like so, okay, so that's our Buret. Obviously we've got the wee tap, and I'm going to draw a conical flask, like so. Okay, now inside a conical flask there's going to be a liquid, and that liquid we're going to have 20 centimetre cubed of hydrochloric acid. I've spelled that wrong. Hydrochloric acid. Okay, and in our Buret, yeah, we're going to have another liquid, and in there we're going to have 0.5 centimetre cubed, 0.5 mole per litre of sodium hydroxide. Okay, 0.5 mole per litre of sodium hydroxide. The next part, so the results of the titration are given below. Okay, and what we're going to do, we're just going to create a wee table. And we're going to have a couple of headings. Well, we're going to have 4 headings. We're going to have the titration. We're going to have the initial Buret reading in centimetre cubed. Okay. We're going to have the final Buret reading in centimetre cubed as well, obviously. And finally, we're going to have our titer in centimetre cubed as well. Okay. Now, so the initial Buret reading, that's the value of the Buret before we start the experiment. Okay. The final Buret reading, that's reading on the Buret once this reaction has completely finished. Once we've got that colour change, Yeah, remember we add the indicator in, okay? And in the case of this one, it went from clear to purple, okay? The minute it turned purple, that's when the reaction was over. That's when the sodium hydroxide had fully neutralised the acid, okay? So before the experiment starts, after the experiment's finished, and the titer is how much we've used, but I'll explain that when we start looking at this. Now, I've got different values here, okay? Now, we're going to look at the first two. So this is titration number 1, titration number 2. So I did this experiment 3 times, okay? We were just going to look at the first two just now, and you'll see why I had to do it 3 times. So in the first experiment, the titer value was 2.2. Yeah, before I even started the experiment, I filled up my Buret all the way up to 2.2 centimetre cubed. Okay, and then I started the experiment and it neutralised, yeah, there was a colour change when it went to 12 centimetre cubed. Okay, so what that means, because we started at 2.2, yeah, we finished at 12.0, okay, that means our titer, the amount we've used, is 9.8, because that's the difference between the two. Okay, now I did that titration again, and obviously I started at 12 because that's where the last one finished at 12, so the next experiment started at 12, and this took me, once the experiment finished, took me to 20.2 centimetre cubed. Okay, so that means we started at 12, we finished on 20.2, so that means we used 8.2 centimetre cubed. Now, the reason I had to do a third experiment is because, remember what I said in the last video, your two titer values, they have to be concordant. Okay, and if you remember what concordant means, that means they have to be within 0.2 of each other. Now, unfortunately, these aren't within 0.2, so I had to do the experiment again. So I started, obviously experiment 2 finished at 20.2, so I'm starting at 20.2, and my final Buret reading was 28.5. So here, the difference between these two is 8.3. So your titer is how much you used. Now, I never had to do any more experiments, because if we look at this, these two values here are what we call concordant. Okay, they're within 0.2 of each other. They are concordant. That's very important. Okay, now let's start doing this question. Now, the first question, it was split into 2 parts, part A, part B. So part A was calculate the average volume of hydrochloric acid that should be used in our calculation. Okay, so that's the first question. Now, you only need maybe 5 or 6 lines for this, so don't worry about it, and we are going to come back to that. Now, the next question is B. Okay, so the equation for this reaction is, and I'm going to write it for you. Okay, so we've got sodium hydroxide, we add it to hydrochloric acid, and obviously we've got an acid, we've got a base, we are going to get a salt, which is sodium chloride, and we're going to get water, and the equation is already balanced for us. Okay, so what the question is wanting you to do is calculate the concentration of the hydrochloric acid. So that's our two questions. So we'll come back to B just now, yeah, and we'll look at question A. So what we need to be able to do is we need to be able to extract everything from this question and use it in our calculation, and that's the hardest part about these calculations. Sometimes it's nice and easy, like the questions we were doing last lesson, okay, where it's already given you the values, but more often than not, it's set up like this and you need to extract all the wee pieces of information out. So the first question A, calculate the average volume of hydrochloric acid that should be used in our calculation. Now, before we start, I just want to make you a wee star, yeah? So the values found in the table come from the Buret. Okay, so what I'm saying there is these values here, these titer values, those volumes are coming from the Buret. Okay, so calculate the average volume of hydrochloric acid that should be used in our calculation. Now I'm going to have to change this. Calculate the average volume of sodium hydroxide. That's my fault. Okay, so calculate the average volume of sodium hydroxide that should be used in our calculation. So like I said, the values found in the table come from the Buret. So these values here, the experiment 1, 9.8, 9.8 came from the Buret, and it's sodium hydroxide that's in the Buret. Okay, titration number 2 is 8.2. Okay, so 8.2 centimetre cubed came from the Buret, which is the sodium hydroxide. Now, this question, calculate the average volume of sodium hydroxide, yeah, that should be used in our calculation. Now, what a lot of people do is you've got 3 titrations, yeah, you've got 3 titer values. What they do is they'll add them up and then they'll divide by 3, okay? But you need to, it's so important that you take the average of the concordant values, okay? So that's very important. Take the average of the concordant values. Okay, now you need to know how to take an average. So you add up the numbers that are involved and then you divide by how many are there. So our average between the concordant values, which is 8.2, 8.3, we add them. So 8.2 add 8.3, and because there's 2 numbers, yeah, we divide by 2, and you can do this in your calculator, but the average is 8.25 centimetre cubed. Okay, so it's very important when it's asking you to calculate the average of the volume used, you use the 2 concordant values. Okay, so what we'll do, we're just going to do this question here now. Okay, so question B, the equation for the reaction is sodium hydroxide plus hydrochloric acid goes to sodium chloride plus water. Okay, so the question wants you to calculate the concentration of hydrochloric acid. Now, like I always say, before any sort of calculation, you want to write what you know. Okay, you want to write what you know. Now, for this, we need to look at the question. Now, what do we know looking at this diagram? Yeah, to the Buret, the sodium hydroxide, we've got 0.5 moles per litre. Okay, moles per litre is a concentration. Okay, so the sodium hydroxide, our concentration is 0.5. Okay, now our volume, yeah, remember whatever's in the table is talking about whatever's in the burette. So because these values are in the table, it's the sodium hydroxide that it's talking about. So our average, and you always use the average, is 8.25 for the sodium hydroxide. Okay, so our volume is 8.25. Now, remember that we need, because we want to get it into litres, we need to divide it by 1,000, but we'll do that in our actual calculation. Okay, now look at the hydrochloric acid. Yeah, the question's asking us to calculate the concentration, so that's a question mark. Okay, so the information must be in the question. And if we look at this, yeah, look at our conical flask, 20 centimetre cubed of hydrochloric acid. So it tells us the volume there. Yeah, it tells us that we've got 20 centimetres cubed, but remember, we need to divide by 1,000. Okay, we need to divide by 1,000. Now, we've written down everything we know. Okay, and every time you get a calculation, you should always have one of the reactants, concentration, volume, and then you should have the other reactants, volume. Okay, and then we're trying to work out the concentration. So, now that we've done that, yeah, the hard bit's over. Now it's the easy part. So we split our page into 3. So in the middle, we've got mole ratio. Okay, and now it's a mole ratio between the two reactants. So that's sodium hydroxide and hydrochloric acid, and it's a ratio of 1 to 1. Okay, so the hydrochloric acid is at the right, and then the sodium hydroxide is at the left. Okay, now what side do we start on? We start on the side we start on the side that we have the most information about, which is the sodium hydroxide. So we start here. Okay, and we always calculate our moles. We've got our concentration, we've got our volume. Now, our concentration is 0.5, okay, and we times that by our volume. Now, we need to divide by 1,000 here. Okay, so 8.25 divided by 1,000 is 0.00825. Yeah? Now, if we put that into our calculator, so 0.5 times 0.00825, we're getting 0.004125 moles. Okay? Now, we bring this over, okay, so 0.004125 gives us 0.004125 because it's 1 to 1. Yeah? And finally, in our last box, we'll always do what the question's asking us. The question's asking us to calculate the concentration, so that is what we're going to do. So that's C equals N over V, because we need to rearrange N equals CV, obviously, so bring the V down. And obviously the number of moles comes from the middle, so that's 0.004125 divided by our volume, which is 20 divided by 1,000, which is going to be 0.02. Okay, and if we do that in our calculator, we are going to get 0.2, round up, 1 mole per litre. Okay, so that's how you do that question. Now, your calculation is exactly the same as we were doing earlier. Yeah, that doesn't change. How it changes is the question looks complicated. Okay, so read the question. Moles per litre, that's your concentration. Volume, centimetre cubed, that's your volume. Now remember, whatever the values are in the table, that's talking about whatever's in the burette. Okay, so these values here are talking about the volume of sodium hydroxide. Okay, so be very careful with that. And remember, we always need to calculate the average titer value. Okay, and you can only calculate the average between the two concordant values. Okay, right, I'm going to put up some practice questions for you to do in teams, and we'll see how we get on. Thank you.